Lesson comes from 11.4 in Go Math, where we're focusing on determining the surface area of pyramids. The essential question does in fact read, how can you find the surface area of a pyramid? And today's focus will be just that. I think it's important that we reference yesterday's lesson, of which we were looking at surface area of prisms, and just being sure that we remember that what classifies a pyramid or a 3D shape that's in that family, as we say, kind of like the last name, is that there's only one base and all of the other faces are going to be triangular. Underneath the essential question, it reads, most people think of Egypt when they think of pyramids, but there are ancient pyramids throughout the world. The Pyramid of the Sun in Mexico was built around 100 CE, Common Era, and is one of the largest pyramids in the world. Now, the Unlock the Problem says that Kara's making a model of this Pyramid of the Sun for her history project. The base is a square with a side length of 12 inches, and each triangular face has a height of 7 inches. What is the surface area of Kara's model? Now, I think we should underline what the question's asking us to find. What's the surface area of Kara's model? We definitely want to circle the important facts. We know that the base is square, and that side length is 12 inches. The triangular faces have a height of 7 inches. I'm also just going to take a moment to just highlight the number values there. And I guess one of the things that I would want to box in is this idea of surface area, because I know I'm looking at the sum of the area of all of the faces. And the fact that it's a pyramid, I think I want to keep that in mind as well. All right. Notice off to the right, they have the net drawn for you. And that's because when we're working with surface area, it's really very helpful if we look at drawing the net. It takes apart the shape from this abstract kind of thing that we can't see to making it something more concrete that we now can manipulate and work with. All right. Labeling the dimensions of the net of the pyramid is what they ask us to do. Well, it says that the base is square with a side length of 12. So in a square, if all the sides are going to be the same, this side is 12, then this side is also going to be 12, and that happens to be 12, and that happens to be 12. And that's important because now as we're looking at finding the surface area and looking at the different shapes that make up this net, it's going to help us, I think, a bit more. Oops. All right, so moving on, we want to also be able to look at the other shapes that are in this net. And we always say, what do you see as a mathematician when you're looking at an equation, when you're looking at a geometric shape? And here I see a square and I see 4 congruent equal triangles. This square has an area of 12 times 12 because it's side squared. So that's 144 inches squared. And remember, Kara's height of the triangle is 7. So this right here is going to be 7. Well, if the base is 12 and the height is 7, then that means that I'm going to be looking at finding that area by using the formula 1/2 base times height. And so that's there right here. The area for a triangle's formula is listed there. And now we know that we're just going to substitute the values in. We've got 12 for the base and 7 for the height. And so that looks like us doing 12 times 7, or half of 12 times 7, which half of 12 is 6. And we know 6 times 7 is 42. And again, since this is 42 and this right here is 7, 7 times 12, 42. This is going to be 42 as well. This will be 42 and this will be 42. If I'm going too fast, here's just the breakdown. We made a net of Kara's pyramid. What we determined that because of the base being square, we're just going to look at side squared. And they already told us the side length happens to be 12. And so this square right here happens to have an area of 144 inches squared. Well, because now we've got these triangles that are going to be congruent, each of them is going to have the same area. And if the side here is 12 in the square, that means the base of the triangle is also 12. That means that if this height is 7, I'm going to take 1/2 base times height to give me the area of each of those triangles. I think we just got to fill in one other piece of information that we skipped, and that was the 12 squared equaling 144. Now you guessed it, to find the surface area, if you did anyways, we now have to add all of these up. So we're looking at the 144, which was the area of the square, plus the 42, 42, 42, 42, and there's 4 triangles that are 42 inches apiece, and that ends up giving us, where we're looking at 42 times 4, 168, and we're going to add the 144 plus the 168 together to give me a total surface area of 312 inches squared. And here we go, 312 inches squared. Let's look at the next example on the next page. And I think that that one, since it's so connected, it's going to be pretty easy for us to zoom through. So sometimes you need to find the total area of lateral faces of a solid figure, but you don't need to include the area of the base. The lateral area of a solid figure is the sum of the areas of the lateral faces. Well, what's the lateral faces? Lateral faces are faces that are not the base. So when you're looking at finding lateral area, you're just going to be looking at anything that's going to be an area, but not the bottom, not the base. So that would be here, kind of outlined, and then it's hard to see, but then also that one that's outlined here. Okay, not this space. So again, let's draw the net for the shape. That's going to be pretty straightforward. Since it's a triangular pyramid that we know Trevor's making right here, he's looking to just basically make the 10 of fabric. But since the bottom is going to be left open, and that's really something I'm going to make sure I kind of pronounce or make sure I stand out. If the faces have a height of 10, and a base of 6, what's the area of the fabric that he's going to use? Well, again, back to my making of my net. Here's a triangle. I'm going to classify this as the base. And if it's a triangular pyramid, then guess what's going to happen? I'm going to have triangles coming out here. I'm going to have a triangle coming out here. And I'm going to also have a triangle coming out here. Now, it mentions that the faces have a height of 10 and a base of 6. Well, here's my height, 10. Here's my base, 6. Height, 10. Base, 6. Height. I know this is a really bad sketch. But really, when I sketch out a triangular pyramid, although, yes, I'm not including the base, and in this case, all the other faces are congruent, identical to one another. I just have to really look at substituting the 6 in for the base, the 10 in for the height, because here's my formula that I use. And what's 1/2 of the base times height, or 1/2 of 6 times 10? Well, 6 times 10 divided by 2, or half of 6 is 3. 3 times 10 is 30. And so in this case, since I'm just looking at only the lateral faces, I'm looking at this face, and this face, and this face. And each of those lateral faces happens to be where the area is 30. Then all I have to worry about is adding 30 to 30 to 30, which gives me 90. And so the lateral faces are simply 90 feet squared. So Trevor needs 90 feet for fabric. Again, remember, the big important thing with this particular problem was that we were just looking at lateral area. We were not looking at surface area. There is a difference. Surface area is the sum of all the faces. Lateral area are all of the faces that are not in place, the base, not including of the base.